Kids, today we're going to review section 10.3, geometric sequences and series. I have the formulas down. Unlike arithmetic sequences, geometric sequences are generated by multiplying by a common ratio. In arithmetic, you added a common difference. Here we're going to multiply by a common ratio. So to find the nth term, you take the first term times that ratio and raise it to the n minus 1, where n is the number of terms. To find the sum of a geometric sequence, otherwise known as a series, you take the first term times the quotient 1 minus r to the n over 1 minus r, or if you have the last term, you can use the formula first term minus last term times r all over 1 minus r. If a series is infinite and it converges, which means the ratio, the absolute value of the ratio is going to be less than 1, then you can find an estimate to what that series would be. And you would take the first term and just divide it by 1 minus r. We're going to look on page 608 at examples 1, 3, 6, 7, and 8. Okay, let's go. On example 1, A part, we have 8, -2, 1/2, ... And it wants us to find the common ratio in the next 3 terms. Sometimes common ratio is obvious to you. If it's not, to find the common ratio, you'll take the second term and divide it by the first term. Third term divided by the second term, any of those 2 consecutive terms. So when I take -2 and divide it by 8, I see that my common ratio is -1/4. Now to get the next 3 terms, I just continue multiplying by -1/4. So when I multiply 1/2 by -1/4, I get -1/8. When I multiply that by -1/4, I get 1/32. And when I multiply that by -1/4, I get -1/128. So once you find the common ratio, you just continue multiplying it. If that common ratio is negative, then your signs will alternate. On B, we have expressions, but we can still do the same thing. Our first expression is w plus 3. And then we have 2w plus 6 and 4w plus 12. I can see that going from one term to the other involves a ratio of 2. If I multiply that by 2 and that by 2, I get 2w plus 6, and so on. So to get my next 3 terms, I just multiply by 2. So I'd have 8w plus 24. And then when I multiply by 2 again, I'm going to have 16w plus 48. And by 2 again, I'll get 32w plus 96. So very similar to the first lesson where you're just finding the next few terms of a pattern, except all these patterns will involve multiplying by a common ratio. Okay, let's look at example 3. Example 3 is asking us for the nth term. So we got 189 is my first term, 151.2 is my second term, 120.96, and so on. So the first thing I need to do is to find my common ratio. I'll take my second term, divide it by my first term, and I get 0.8. And they are asking me for the 27th term. So to find the 27th term, I use that a sub n formula. Remember that a sub n is equal to the first term times the ratio raised to the n minus 1. So I would have 189, and then in parentheses, I'd multiply that by 0.8 raised to the 27 minus 1. At this point, I wouldn't probably put it in my calculator. I would just go ahead and subtract that 1 and say 189 times 0.8 raised to the 26, and put that in my calculator exactly the way we have it written, and I get for my 27th term 0.57. So the pattern is getting smaller and smaller. If we're multiplying by 0.8, it's like taking 80% of it. And so by the time we get to the 27th term, we just have 0.57 left. Okay, let's move on to example 6. In example 6, we're going to be finding the sum, which is the series. So in example 6, they want me to find the sum of the first 6 terms. And I have 8 and 14 and 24.5. So they give me 3 terms. I may just want to go ahead and generate the sequence and add them all up, which we did in the first section too when we had that sigma notation. But I can find the ratio and use the formula. So in finding the ratio, I take the second term and divide it by the first term, and I get 1.75. So to find the sum of the first 6 terms, I use my sum formula for a finite series, which means that it ends, and that is S sub n is equal to first term times the quotient 1 minus r to the n over 1 minus r. So my first term is 8 times, and then in parentheses, I'd have 1 minus 1.75 to the 6th power over 1 minus 1.75. You need to be careful when you're putting this into your calculator. In fact, you may want to do the numerator and the denominator separate and then divide. Or put you a bunch of parentheses. If I was just trying to do it in my calculator in one clean swoop, I would do it this way. 8 times, and then I would have open parentheses, and then I would put another parentheses for the numerator. Divided by, and then a parentheses for the denominator. Close the denominator parentheses, close the one I opened for the whole fraction. And shouldn't have any trouble then getting the correct answer. And that is adding all 6 of those terms up, I get 295.71. Okay, there's a B part on this one. Let's look at that. So we're still looking at example 6. So on B part, they want me to find the sum of the first n terms, and the first term is 3, and the last term is 768, and this ratio is -2. So in the introduction, we saw 2 formulas for sum. This one is going to use the one where a sub n is involved. So that's S sub n is equal to the first term minus the last term times the ratio all over 1 minus r. So the sum of n terms, I don't know how many n's there are, but since I have the last term, I don't have to have n. So I say 3 minus 768 times negative 2 all over 1 minus a negative 2. One of the common mistakes, students want to go ahead and say 3 minus 768. Remember, you multiply before you combine, so I got to do this first. But if you'll put it in your calculator with parentheses, 3 minus 768, parentheses negative 2. So you have a parentheses for the numerator, and then you have a parentheses for that negative 2. And then I would just go ahead and do 1 minus a negative 2 and say divided by 3. Keeps me from having to do another parentheses to get my sum of 513. Okay, so when they give us a sub n, we're going to use that second formula. All right, moving on to example 7. Example 7, we saw some problems like this in last lesson where we had sigma notation. Same kind of thing in this one. In example 7, instead of having the sequence written out, they asked me to find the sum. That's what they're asking for with that sigma. When n is 2 to 7, and then I have 3 times 5 to the n minus 1. So I'm going to generate a couple of these so I can get my first term. And so when I put a 2 in, I get 3, 5 to the 2 minus 1. 2 minus 1 is 1, and 3 times 5 is 15. If I needed to do it again to see what my ratio is, I could, but this 5 raised to the n minus 1 mimics the formula. First term r to the n minus 1. So we see that r is 5, but I could do another one just to make sure. So it'd be 3, 5, 3 minus 1, and then 3 minus 1 is 2, 5 squared is 25, times 3 is 75. 5 times 15 is 75, so I see that my r is 75. My r, I'm sorry, is 5. So then I use my sum formula. So first term is 15. And then I can do 1 minus r, which we found out was 5. Raised to the n, and then we got to see how many terms we have. If we start at 2 and we go to 7, we have 6 terms over 1 minus 5. And then it's just a matter of putting it in your calculator. Once again, if you're going to do it in one swoop, you'll need to put parentheses around the numerator, parentheses around the denominator. And the sum of these 6 terms ends up being 58,590. Or we could have used the other one and put a 7 in and had our last term, and we get the same answer. Either way. All right, the last example we're going to look at, example 8, is when you have a infinite geometric series. So this formula is that we used on example 6 and 7 was for finite, which means we knew how many terms we had. For infinite, we have dot, 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 indicating all of it. And a lot of times he'll ask us to find, if possible, the sum. So on example 8, that's what they do. They say, if possible, find the infinite geometric series for 9, 3, 1, and so on. So the first thing we do is find our ratio. So I'll take 3 over 9. 1/3. 1/3 is less than 1, so I can use the formula. And the formula, I like to put an infinity sign here. when I'm using this one, just so I don't get it mixed up with my other one, is first term over 1 minus the ratio. So if I'm going to put it in my calculator, then I would have 9 divided by parentheses around that 1 minus 1/3. If you don't put parentheses, your calculator is going to divide by 1 and then subtract 1/3. So you'll miss it. Or you could do 1 minus 1/3 separate in your calculator. That's 2/3. And then 9 divided by 2/3, we invert that and we get 27 halves for our final answer. Because if we were generating this by 1/3, it would get so small that those last few numbers would not be very important to the sum. So that's why we have a formula for infinite geometric series. All right, there's a B part. Let's look at that. We got 0.25 negative 1.25, 6.25. So to find our R, we're going to take our second term, divide it by our first term, and we get an R of -5. Well, the absolute value of -5 is not less than 1, so this one is not possible. So remember, in that formula, in our very first page when we went over our formulas, it said that the sum for an infinite series, first term over 1 minus R, if the absolute value of R is less than 1. If it's not, then it's not possible, which means that the pattern is not decreasing. It's not converging to a certain value. All right, and then there's the C part. In C part, we have our sigma notation, and we're going to start at 4 and then go to an infinity sign. So I got 4 times 0.2 to the n minus 1. This is mimicking the formula first term times r to the n minus 1. So that indicates that this r is 0.2. But if you wanted to substitute a 4 in and get your first term and generate it, you would say 4 times 0.2 to the third power, and we get 0.032 is my first term. Then when I put a 5 in, I get 4.2 to the fourth power, and that's going to give me 0.0064. I can see it's getting smaller and smaller. If I divide that by that, I get 0.2. So I'm ready to do my sum. And this is for infinity. So I take my first term, which we saw was 0.032, and I divide it by 1 minus the ratio. If you're going to do it in your calculator in one clean swoop, let's put parentheses around that. Or you can just say that's 0.032 divided by 1 minus 0.2 is 0.8. And then when you divide 0.032 by 0.8, you get a sum of 0.04. So using your formula is quite a bit. All right, so in our assignment sheet, you'll see that the assignment's going to be on page 615. We're going to do 2 through 8 even. That's like example 1. And then we're going to move down to 20 through 26 even. That's like example 3. And then we'll do 40 through 46 even. That's like example 6. On page 616, we're going to do 48 through 54 even, like example 7. And then 56 through 62 even, and that's like example 8. So really, we can combine these last ones together. I just wanted to specify that they are like those examples. So our homework, our assignment is 2 through 8 even, 20 through 26 even, and then we'll do 40 through 62 even. Okay, email me if you have any questions. Look back at the video if you get stuck on something. And miss you guys and look forward to hearing from you. Thanks.